I'm Anurag. I'm a principal engineer at Twilio. I've been with Twilio for almost like 4 years, and my team, basically, if you're not aware of Twilio, what Twilio does is it's a telecommunications company. So if you're receiving SMSs, email, voice calls, or if you have interacted with any kind of chatbots and use a food delivery service like that, so we take care of all those things, right from a contact center for sending emails, SMS, and a bunch of other things. But today we are not going to talk about that, but we are going to talk about a very important problem in that domain, which is basically fraud. So if you attended the morning keynote from Risha, she mentioned that every year during BFCM and Black Friday and Cyber Monday, basically you come across a lot of fraud, which happens. So we do work with banking customers, and she was like absolutely right. So there's a lot of tons of frauds that happens for all kinds of systems, and mostly banking systems. So yeah, we'll deep dive in a bit into like the type of fraud, how CPaaS is, which are basically communications platform as a service, they handle it, and yeah, we'll take it from there. Again, like this is my first presentation, so pardon my stammering and all those things, but yeah, have fun. If you have any questions at any time, just raise your hand and I'll try to address those. So yeah, every day you might receive some or other form of communication via notification, a phone call, email, something else, right? Or it could just be a spam message that you receive that, okay, earn $5,000 a day or 5,000 rupees a day by doing some work from home. So yeah, we take care of all those stuff except the spam. That's what we capture. So in the next 20-25 minutes, we're going to talk about what artificially inflated traffic in telecommunications system is, how communications platform as a service help, what options are there for developers, what options do we provide, what additional things that like we as a company and all other CPaaS, our competitors also provide to help mitigate fraud. And finally, we'll talk a bit about how we at Twilio like battle fraud and what's the business impact of all of this. So artificially inflated traffic or SMS pumping, it's basically a telecommunication fraud where bad actors exploit messaging services. So what happens basically is fraudsters, they will target vulnerable businesses. So these are mostly pull-based businesses. So there are two kinds of messages. There's push-based and pull-based. Push is your marketing campaigns. Like whenever I send any marketing message to you that, oh, go shop for this, or this 10% off on this. So those are push-based messages. Pull-based messages, like for example, you're ordering food and you receive an OTP. So those are pull-based messages. So fraudsters mostly identify pull-based businesses, which are vulnerable businesses. These could be banking sectors, social media apps, or almost every business requires you to do a two-factor sign-in. So yeah, and what fraudsters do is they work with these shady mobile network operators. So these mobile network operators, these could be carriers, and they also are responsible for actually selling numbers, like phone numbers. So what fraudsters do is, in order to get revenue, they will partner up with these mobile number operators and they'll try to identify these businesses and inflate the traffic on the system. So that's what AIT means, artificially inflated traffic. So this leads to loss of revenue for customers. Trust of customers is lost again, like with us. And at the same time, there's a lot of compliance and legal problems also for Twilio carriers and customers. So if we look into a few numbers, like the Mobile Ecosystem Forum said that by the end of 2025, each year we'll start sending almost 2.6 trillion messages. And these are A2P messages. A2P messages are nothing but application to person. So basically, a business might be sending out a message to you. For example, if you're ordering food, you receive an OTP, so you can consider those as an A2P messages. And out of that, almost 5 to 40% of messages might be fraudulent. So this again depends on the country where the message is going to originate or where the message is going to terminate. So up until 2021, the time till most of the CPaaS providers, they didn't have any fraud mitigation solutions in place. So most of them, what they did was, okay, once the fraud has happened, they'll try to identify, they'll do a lot of manual efforts, manual things, and try to block certain phone numbers or countries. So there was a loss of almost like 6.7 billion up until 2021. If we just take a look in the next slide, like you will see, these is the fraud. So like almost every country except if you look at Northern America and Canada is filled with fraud. And if you look at mostly South African countries and Middle Eastern countries and our neighbors, they are like very, very prevalent in like doing fraud in the systems. So almost all countries, and we do see certain amount of fraud in US and Canada as well, but it's very less. So like what is fraud? Like I keep talking about this like this word, right? There's fraud all the time, but like what does it mean? So there are a bunch of signals that help us identify fraud. Like for example, you will have unusual sequences of phone numbers. So like I said in the earlier slides, these hacker groups, bots or bad actors, they partner with MNOs and they buy numbers. So these numbers are incremental in nature. So you will see like 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 0, 0, 0, 0, 1, 0, 0, 2. So these would be series of numbers that they'll buy. And these numbers will be used to initiate verification or SMSs, A2P SMSs. You'll start noticing high delivery failure rates because a lot of times these messages will terminate to the numbers which are never converting, or they are like kind of a disposable numbers. Then you will see spike in single or multiple country codes. So whenever a fraud happens, earlier it used to happen like the patterns, like it evolves. Like we have evolved since 2020. So earlier we used to see, okay, fraud is happening in one specific CTMNC or a country or a particular region. But now we have started seeing patterns where multiple countries or multiple accounts or multiple customers get affected at the same time. Then there's this bot-like behavior. So again, there's something called as a feedback mechanism. What feedback mechanism is, let's say you order something from a food delivery site, like you order some food and you get an OTP, you enter that OTP, and if you enter the right OTP, order gets placed, right? So when the order gets placed and you enter the right OTP, a feedback is sent back to the business, and they can forward that feedback to us. So that is some conversion ratio or conversion rate. That, okay, I sent 5 messages and out of those 3 converted. So my conversion rate is 3 by 5. Like you do the math, I'm bad at it. So yeah, so if there is a conversion which is happening very, very fast, like a human can enter an OTP in a period of like 2-3 seconds, like you will take some time to read the OTP, then enter it. But we have seen cases where like you get a message and immediately that gets converted, like in a period of a few milliseconds to less than 2-3 seconds. So we have defined certain thresholds to identify if there's a bot-like behavior or not. Then you have disposable temporary numbers. So in US, mostly you would come across the throwaway phone numbers that you can easily buy. Within India also, there are a bunch of websites where you can get temporary emails, temporary phones to receive certain OTPs. So yeah, we kind of identify those numbers. And like I said, like earlier, so these are mostly targeted to verification related messages, which are basically your pull-based messages, SMSs. So if you think of fraud, like you'd see, okay, it's fraud. And I talked about terms like artificially inflated. So it might be at spikes, right? So that's correct. Like the first one, like you will see an instance of high volume fraud, which is basically, okay, things are normal till I would say 4th of April, and then suddenly you'll see a spike. Fraud detection works, it comes down, and another day you will see another spike. Then there's something called as low volume fraud. So this is something pretty, I would say, pretty new compared to high volume, because like as we evolve, our systems evolve to mitigate fraud, fraudsters also evolve because they have to find ways so that they can make money out of these systems or by exploiting businesses. So we started seeing this kind of patterns where this doesn't look like fraud, but it is actually fraud. So they will replicate the behavior, which is much more like followed a sun kind of a pattern, or like which will look like a daily traffic. You'll have your peaks, you have your lows, but it's fraud. So it becomes very hard for us to judge whether this is fraudulent behavior or not. So what developers or businesses that use CPaaS providers, or like if if your businesses are sending out SMSs, or your startup, or you have an app which sends out SMS calls or any things, like what options do they have today, and what do they do? Like what we also recommend our customers to do. Like first of all is like your disable countries where you don't do business in, like the straightforward thing. If you don't do business in Iran, Middle Eastern countries, don't send, just disable those countries so that you, even if you incur fraud, you don't get charged. Then you have capture. You can use alternative mechanisms. Like you should have two-factor authentications if you're using a console-based applications. Alternative challenges. SMS is prevalent with fraud. You can explore different channels like WhatsApp, where you have fixed templates. You can't actually go ahead and just do frauds. And there are, you can have voice. There are a bunch of other channels also you could explore. Rate limiting. So most of the businesses today, in order to protect themselves, they will implement some kind of rate limiting system. So that not only just safeguards their systems, but it will also safeguard the revenue that they will lose because of fraud. So, because if you just look at this image, right? So they were sending around, like this is for one sample customer like that was sending around 10,000 messages on average, and it almost spiked 3x. So if you consider like, and any businesses that onboard could have varied amount of varied amount. So for big companies, this could be a huge, but for a startup, which is like a very small customer, the 3x sudden spike in the traffic or 5x, 10x sudden spike in the traffic is actually a lot of runway for them that gets lost. So so we talked about what options are available as of today, but what developers face issues with today. For them, it's really hard. Like, for example, if you look at the low volume fraud slide, it becomes very hard to identify or segregate fraudulent versus legit traffic. They don't have access to line type intelligence, whether this is a mobile number, landline, voice over IP, or a disposable phone, or any of the threat signals that we have information because we have been doing this business for a long, long time, or any CPaaS provider for that matter. Provider uncertainties. So like any aggregator or CPaaS provider, they work with carriers to send out messages. So these carriers could also be providers or aggregators who actually hop on. For example, if you use Jio, Airtel, AT&T, Verizon in the US, these are all providers or carriers who send out your message actually. And Twilio, Livio, all of these CPaaS providers, basically, they are nothing but just aggregators. They'll do a bunch of things. They will make these things very easy for you to send out those messages to carriers, and carriers will eventually forward that message. What if a provider goes down? So that becomes a headache that business shouldn't deal with. Apart from that, there are a bunch of other problems like welcome problem. Any new customer that onboards, right? You don't have any historical traffic. Like how do you mitigate fraud for those scenarios? New provider, same goes for if businesses, like if an aggregator or CPaaS is kind of onboarding a new provider or a new carrier, we have the same problem, no feedback. So this is actually a huge problem. There are entire programmable messaging or SMSs. Not a lot of cases, almost in 70-80% of the cases, you won't even receive a feedback that the message actually converted. So again, you have to look into a bunch of other signals to identify. So on the right, there are list of all the CPaaS providers that we have today in the market. And what was the use of these CPaaS providers? Like today they go beyond delivery. So their focus is not just to send out message, but also to protect the customers, businesses, themselves, and also the carriers. So yeah, they are first responders in fraud detection. They detect, block, mitigate fraud. They take care of network. Like if they notice that there's a lot of fraud happening, or if network is down, one of the carriers is down, they immediately switch to a different provider. Then obviously, if they are first responders and they can help mitigate fraud, they ensure that, okay, the network is in stable condition, then they can save a lot of revenue for themselves and for the customers. Communications platform as a service. So like any item that you see on the right side image, so those are all communications platform providers. So basically, you sign up for Twilio and you can send message. So Twilio is a CPaaS. Yeah. So yeah, and to the problems that I mentioned above, how those are solved. So the welcome problem. So like all CPaaSs, and including us, we built something of a system as progressive trust. As soon as a new business signs up, you need to have some kind of information. Like obviously you have AI ML models which train on their traffic to identify the peaks, the lows, and all those things to come up with certain level of thresholding to identify when to block. But there's this concept of progressive trust. As in they grow with us, we kind of relax the limit so that they can send more traffic. Then continuously on classification. So you have seen other accounts, how they provide in isolation, and you can apply those learnings for the new customers. New providers, every time a new carrier signs up or partners with any CPaaS providers, they can't just blindly trust, because they might end up doing a lot of fraud, and they can send fake delivery receipts. So what fake delivery receipts are, basically carriers are very notorious. For example, I don't want to name names, but let's just take a random example. Let's say, for example, you send out a message like to Twilio queues a message to Geo to send out to you. So what Geo could do is, Geo might not send out that message. They would rather fail that message on their queue, and they would just send a back. Sorry. They would send a DLR back that, yeah, we sent out that message. So those are called fake DLRs. So yeah, for the yeah, they do. They're notorious. So okay, so you think of it as a problem, like there's so much traffic to handle, and most of these carriers, right, they can't handle all of that traffic. So they will also use alternative carriers. So it might think like that when Airtel SIM, you'll always get messages from Airtel. It doesn't happen. So Airtel will try to send out a message. If they're blocked or choked, then they will fall back on Jio or some other carrier. And they just have, it's just a trust-based system that, okay, they might send out the message. And every hop, there's some revenue sharing which happens. But it's not always that, it's just kind of a load balancer. They have to balance a load. I'll try to send the message. If I can't, my queue is full, then I'll queue it to some other provider. So we have seen messages that go up to like 8-10 hops as well before it reaches an end user. Does that answer? Yep. So, yeah. So all in all, like the businesses should focus on increasing their business, or like focusing on their business problem. And they should leave, obviously, the solutions that they have work well, but fraud is something that all CPaaS providers have worked a lot to handle. But if you think of it, like no one wants to receive their messages late. If you receive your OTP like a few seconds late, you will just keep on clicking that retry button. Everyone would have done that here in this room, right? So you want to receive it. So that means, and on average, once a message is triggered to the time it is received by a recipient, that is less than a second. P90, P95, you could say it as a second, but all the way it can go up to 24 hours as well in certain cases for bad carriers, fallbacks, or failures in the systems. But, and if you have to perform these kind of fraud detection checks in between, you get a very small window of opportunity to ideally flag that message or let it pass. So the services that our team or like any CPaaS providers, they have to work with this huge streaming data, and they have to solve for this in a very low latency manner. Again, preserving trust, because if you are not proactive, you are more reactive, that, okay, once things have happened, then you go and fix things. That doesn't work for anyone. You have already lost the trust of the customer. Also, you get into a lot of compliance struggles. So yeah, this is like a rough architecture, I would say like 100,000 feet of what actual might look like. So if you, I don't know, like if, so yeah. So basically, if you forget about the bottom part of it, in the simple manner, a sender will queue a message. This sender could be a business, or for this matter, we could just say an end user. Like person A is trying to send it to person B, or a business trying to send to person B. So they'll queue a message. It is handled by some gateway, and then that message is queued to a carrier, and then carrier eventually sends out that message to the end user. But this could be fraud happening in the system, right? So, and so what needs to happen is we have a fraud detection service, which will kind of receive that request. It fetches a few things from cache or Redis, also falls back to DynamoDB or our database. And then you have this huge layer at the bottom, which is fully, I would say, a combination of a data lake plus real-time inferencing and predictive models that we have. So what happens is basically, once the message, so every single request that the system receives pushes an event to a data lake. Every time we run a fraud detection algorithm, we also get to know, right, whether we block this request or we didn't block that request. So that is also pushed to your data lake. Now, again, the scale, if talk to you, so like this layer might be processing almost like tens of billions of events in a single day. So that's a lot of scale. And at peak, you might be processing around 60, 70,000 RPS or events per second. So these needs to be really fast. So anyone on the data lake side of it might be aware of these copy on write and merge on read kind of tables. So copy on write are more, they are less read optimized, more so basically you won't have duplicates in the system and all those things. Merge on reads are basically when you query, when you're trying to read that data, at that time you could have duplicates across different partitions, but it will merge and will fetch the latest value. So basically you have these Kafka syncs, and then also you have this Elasticsearch, because Elasticsearch is great at doing all kinds of aggregations, like real-time aggregations. You want to count stuff. Again, like we have to build a real-time system. If a fraud is happening, we have to react within a few seconds. So you need to stream that data, build a feature out of it, and work with Elasticsearch and these features, come up with certain threshold and push it back to the service so that service can actually take actions on these messages. Yeah.
Take the body, how do you know about that? It is mitigation, right?
Yeah. So this happens at this layer in the fraud detection layer. So for example, so there's just not one solution. Basically, if you look at it, there could be a lot of fraud, like it could be a phishing related, like you get spammy messages, abusive messages. So those are in different domains. So this is mostly on volumetric fraud. So the volume that...
I think not only work.
Yeah.
People who accept that to help to they take work center.
Yeah. So shorten URLs are, so that's what, those are marketing kind of messages. Those are not OTP messages. So fraud mostly happens for OTP kind of messages because you request the message there.
Same way.
No.
This occurrence that any says that to be too matter.
Yeah.
That can be considered like the SMS pumping fraud.
Actually, no. So if it depends again, what is the intention of that message? If it is a marketing kind of a message, you would expect, like for example, Nike is running some kind of Air Jordan campaign. So yeah, in those cases, yes, you would.
Sorry, I'm asking you this. They say I have primary we have to every customer they create and SMS traffic to go
yeah.
And I registered the name on primary my factor is like the basic primary one, how to sort of lay on anything I did good practice in that primary. So that it all
so there are certain account level configs that we have in the system which allows you to, but so there's something called as inherit master account. I think we can sync like after the session where I can give fine granular details, because I got that we have 4 minutes left. Okay, so yeah, battling real-time fraud. So the whatever we saw in the previous slide is, I'll just quickly cover this, like you're ingesting tons of signals from, like, for example, phone families, origin, destination, geography, all those things. You take those signals, you transform them into incremental features. You push those features which are used by your adaptive models to come up with certain thresholds. So I'm talking about thresholds, and every time a request comes in, I count it. So this looks like a very stupid very simple, elegant implementation. I would say that, okay, if your count is less than threshold, you allow the request. If not, you fail it. But it doesn't work like that, because if you're aware of Murphy laws, if anything can fail, it will definitely fail. So what happens is you have 2 major problems. One is idempotency, one is feature generation. Idempotency is like upstream systems fail. And in the telecommunication systems, it fails more often than you would think. That provider is not able to send out the message. The message gets queued over and over and over again, over 100 times also we have seen. So if you have flagged a message for fraud once, doesn't matter if you are getting it for 1,000 times or 5,000 times, your verdict shouldn't change, and it should not impact the other requests that are coming into the system. Every single request should be idempotent. And feature generation, given the volume of data that you have to ingest, like billions of records you're processing, so you have to figure out the right way, like do you use Elasticsearch, Redis, small file problems, and a lot of those things. So this basically then boils down to like either a sliding log for duplicate look back, basically becomes a bit complex problem. And then we started looking around what we could do, and we found Redis. So if you have used Redis, it's nothing but an in-memory store. Your disk fetch time like goes for a toss. Like it takes a few milliseconds. Redis does things in nanoseconds. There are a few features available here, which I'll skip. But this is something that we use extensively, sorted sets. So sorted sets are nothing but sets which are ordered. So you can order any element or any, like let's say, for example, if you're building a leaderboard, if you're playing a game, you might have seen that, I think New Relic slide, they have a fancy game and they're showing us some kind of a leaderboard, right? That is something we implement using sorted sets. So we started using sorted sets to do a bunch of things. So if I give you a sample, like imagine if you have to track login attempts of a bunch of users. So ZAdd actually adds a member to the set. Login is your set name. The next timestamp is your value, score, and user one. So you add 3 users, and now you can do things like I want to only fetch users who range from this time to this time. And or for users who range all these 3 times, basically I can fetch users in either ascending or descending order in O log n plus m, which is very, very, very fast compared to if you have to do the same thing within disk. So the same kind of implementation we also have. So you imagine like you have to count the number of requests also, and you have to maintain idempotency. So you have to count from the current time till the window start time. Let's say if you have some fixed window or a sliding window, you have to count the number of requests which are unique. So sorted sets provides you that kind of flexibilities. So just to talk about it, that we have in terms of business, like 569 million attempts till October 2024, almost $86 million for customers. I'll skip this. Lessons, like I'll just finish this with this. Fraudsters move fast. They test and probe our systems. They will run bunch of attacks, combinations of attacks of low volume, high volume. It's basically a game of deception for them. They learn because they eventually are out to make money. And for them, it's much easier than us because we have to figure out patterns and then finally build solutions that could actually fix these problems. So yeah, if you have any questions, you can drop by the booth. I'll be there hanging out with my team for another hour. And if you want to try out Twilio, just use this promo code and you get $20 in credit. Join us at booth 28. Thanks a lot, everyone. Have a great day. Bye.